Okay, today we are going to learn about curve sketching. So these are some things that we've already talked about. And so if you take a minute to read through these, and I'm also going to make that chart that we've been referring to. So positive, remember, is above the x-axis, negative is below. Increasing means the slope is positive, decreasing means the slope is negative. And then for these next few, I'm going to make our little table. So a positive f prime means that f is increasing. A negative f prime means f is decreasing. And same going the reverse, increasing f means f prime is positive. Decreasing f means f prime is negative. F double prime positive means f is concave up. And just like with this positive, the one before it is increasing. So here, this positive, we can say that f prime is increasing. F prime being negative means f is concave down. And this f double prime being negative means f prime is decreasing. I'm also going to add a min, a max, and a point of inflection to our table. So if we have a min, f prime is going from negative to positive. So that's an x-intercept on f prime. A maximum, f prime is going from positive to negative. So again, it's another x-intercept. So those are x-intercepts. Just going to put a little note, x-intercepts on f prime. A point of inflection happens when f double prime changes positive to negative or negative to positive, which means f prime is changing from increasing to decreasing, which means it would be a maximum, or decreasing to increasing, which would be a minimum. So points of inflection are mins and maxes on f prime. Okay, so before we start with, we're going to take a graph that you kind of already know what it looks like, and we're going to show you how you can use the first and second derivative to sketch a graph, because way back before they had graphing calculators, they used calculus to graph functions. So we're going to take this first one, and we're going to find the first derivative, which is 3x squared minus 12x plus 9. And we're going to do the first derivative test. So we're going to find where the first derivative equals to 0. So I'm going to factor out a 3. So we have 3 and 1. And I'm going to make a number line and put my critical values, label f prime, and f prime is going to be positive, negative, positive, which means f is increasing, decreasing, increasing, which means at 1 we're going to have a maximum, and at 3 we're going to have a minimum. I'm going to do the same thing for the second derivative. So the second derivative is 6x minus 12. I'm going to find where the second derivative equals 0. So that would be at 2. And I'm going to make a number line for the second derivative. And that would be negative to positive, which means f is concave down to concave up, which would be a point of inflection at 2. Now, sometimes they ask you to compare like where a function's concave down and increasing. So I'm just going to kind of merge these two number lines so that I can put all 3 numbers on it and just show you how you can label f prime and then f double prime. So first I'm going to look at the 1. So less than 1, f prime is positive. In between 1 and 3, f prime is negative. So between 1 and 3, f prime is negative. And then after 3, f prime is positive. Then I'm going to go to this f double prime, and to the left of 2 is negative. So f double prime is negative. And then to the right of 2, it's positive. F double prime is positive. So that will tell you, like, then you can kind of look this interval right here, F is increasing and concave down, where this interval from 2 to 3, F is decreasing and concave up. So that's just a side note. Okay, so now we're going to take these things and we are going to graph them. Well, we have some points now. We have these critical values where there's going to be a max, a min, and a point of inflection. So I'm actually going to go ahead and find what is f of 1, what is f of 2, and what is f of 3, so I can get some points on my graph. And I'm actually going to do f of 0 too, because that's just easy to plug in. So I'm going back up to this function and I'm plugging in 1. And when I plug in 1, I get 2. Then I'm going to plug 2 in there and I get 0. When I plug in 3, I get -2. And when I plug in 0, I also get -2. Okay, so now when we make a graph, whoops, sorry. I'm going to start with plotting those points. So at 1, I'm at 2. At 2, I'm at 0. At 3, I'm at -2. And at 0, I'm at -2. Okay, so then I kind of do a rough sketch of my increasing and decreasing. So this stuff from the first derivative. So at 1, right here, that's a maximum. My f is increasing from -infinity to 1, and I have to hit this point. So I'm going to kind of like do that. Then between 1 and 3, my function's decreasing. So 1 to 3, I'm decreasing. And then after 3, I increase again. So that's kind of the increasing and decreasing intervals. Then I'm going to do my concavity intervals here. So I'm going to kind of fix this graph. So to the left of 2, which is right here, less than 2, my function's concave down. So I need to fix this to be whoops, I have to go through that point, to be concave down. And then after 2, I'm concave up, so I have to fix it to be concave up. So this red line here would be what that rough sketch of f would be. So that's how you use first and second derivative tests to sketch functions. Well, what we're going to do is they don't always give you an equation. They give you clues. And from the clues, you're going to sketch graphs. So we have to review some things and what they mean. So when I have a limit as x approaches a number and the limit is positive or negative infinity, that tells me I have a vertical asymptote at x equals 3. But because this is only on the left side, that means when I sketch this picture and my asymptote at 3, only the left side is going to infinity. I don't know about the right side. Where this next one, it says 5. So that means that both sides of 5, there's going to be a vertical asymptote at x equals 5, but both sides of 5 are going to infinity. When I take limits to infinity, that gives me horizontal asymptotes. So this will be a horizontal asymptote at y equals -2, but it's only positive infinity, so it's only on the right end of the graph. So when I look at my graph at -2, it's either going to do that or it could do that, depending on where the graph's coming from. And so limits to negative infinity is going to still be a horizontal asymptote, but it's only going to be on the left side. And my horizontal asymptote would be at 1. So again, that picture, your graph is either going to do that or it could come from below. Okay, so when we take these clues in order to sketch a function, what I would encourage you to do is go ahead and look. We're trying to sketch a graph of f. So I want to take all these clues and write what's happening on f to help me to sketch my graph. So this first one, it's just giving me a point on f. So I have the point 1, 0. Then I have another point, -1, 0. And then 3, 4. Then they tell me f of 0 is undefined. So that means it's going to either be a hole or a vertical asymptote. I'm not sure yet. Here they tell me f prime is positive. So that means on that interval, f is increasing. F prime is negative. So on these two intervals, f is decreasing. Limit to 0, and I get -infinity means a vertical asymptote at x equals 0, and the ends are pointing down. So I'm going to go back over here where they told me f of 0 is undefined, and I'm going to cross out hole because I just found out it's a vertical asymptote. Limit to infinity means a horizontal asymptote on right at y equals 0. And then the limit to -infinity just means my left end behavior is going to infinity. So now we're going to take all these clues and sketch a picture. So I'm going to sketch it over here. I'm going to start by plotting some points. And I have the point 1, 0, -1, 0, and 3, 4. And then I have that vertical asymptote at 0. So let's put that in. And I also know that my ends are going down here and down here. Change that color. Okay, so then I'm going to start with this first interval from 0 to 3. F is increasing. So from 0 all the way to this point, and I have to go through there, I'm increasing. So I'm increasing. Then from 3 to infinity, I'm decreasing. So I'm going to go decreasing, but I have this horizontal asymptote, so I better draw that in. So on the right side, my graph has to go to that y equals 0, and I need to decrease the entire time. Then my other interval from 0 to -infinity to 0, my function is decreasing. So, and I have to go through this point. So I'm decreasing. Oops, sorry. I'm decreasing and going through that point, and my left end is going to infinity. It says nothing about concavity, so you're not going to be graded based off concavity. You're just going to be you're increasing, decreasing end behavior. And that's it. So that would be a graph of f. Yeah. Let's go to the next one. So now if you want to take a minute to see what's happening on each of these clues, they do tell us that f is continuous and differentiable. So that tells me that we're not going to have any sharp turns or asymptotes or holes. So I'm just going to write as you figure out the clues. I'll just write them so you can check to see if you're doing it right. All right, when you get to E, they're just telling you that the derivatives are 0. So all you know is that it could be a level point, it could be a min, or it could be a max. One of those three things. And when we go to sketch, you're going to figure out which one it is. And then F double prime equaling 0, and this should say at those 2 points. So those 2 points are points of inflection. Okay, so let's sketch a picture. Okay, so as always, I'm going to start with the points. So -1, 3 is a point, and 2, 4 is a point. And then I'm going to do my increasing and decreasing first before I do concavity. So I'm going to go from -infinity to -3, which is right here. I'm increasing. So I'm increasing. And then from -3 to 1, I'm decreasing, but I have to go through that green dot. So I'm decreasing till I get to 1. And then 1 to 4, I'm increasing, and I have to go through that dot. So 4 is there. So I'm increasing till I get to 4. And then 4 to infinity, I'm decreasing. And now I'm going to kind of fix my graph with my concavity. So I'm concave down. -1 is right here. So from -1 and to the left, I'm concave down. So I'm going to kind of make that concave down. Between -1 and 2, this dot right here, I'm concave up. So I'm going to kind of fix that to be concave up. And then concave down again. And so that would be your graph of F. Now, it doesn't matter how high these peaks go and how low the valleys go. So if yours doesn't look exactly like mine, but it's similar, that's still going to be considered correct. Okay, maybe try this one on your own. So maybe pause the video and try it on your own, and then come back and see if you did it right. Okay, so because they said the graph was continuous, when I got to F and they said that the derivative was undefined, I automatically eliminate that it's a vertical asymptote. So it's either going to be a sharp turn or a vertical tangent. So when I go to sketch, the only point they gave me was this point of inflection at 5, 1. So I'm increasing, let me put some more of these points here. So -2 is right there. 3 is there, 5 is there. So I'm increasing till I get to -2. So I don't know where, it doesn't matter where you start. And then from -2 to 0, I'm decreasing. I don't know again how low it's going to go. And then 0 to 3, I'm increasing again. And then 3 to infinity, I'm decreasing. And now I'm going to fix it with my concave up and concave down. So from 0 to infinity, I'm concave down. So here's 0, I'm going to make that concave down. From 0 to 5, I'm also concave down, which means at that 0 is going to be a sharp turn. Then from 5 to infinity, I'm concave up, but I have to continue to decrease. So concave up and decreasing is going to kind of look like that. So again, how high your bumps go, how low, it doesn't matter. This could be at the origin, it can be whatever. All right, the last thing we're going to do today is we're going to make this table, and we're actually going to split this table in half, and we're going to look at not only what the directions say here, we're not only going to take steps to sketch f given f prime, we're also going to sketch f prime given f. And I'm going to start with that because I think that that's mainly what we're going to do today. And then tomorrow we'll do sketching f given, or sketching f prime. No, sketching f given f prime. All right, so the first step when we're sketching f prime given f is to look for where the slope is equal to 0. That's your horizontal tangents. And if the slope is 0, those will become x-intercepts because the y value would be 0. So we make those x-intercepts. Okay, the next thing we look for is where f is increasing and where f is decreasing. And what is that? If f is increasing, f prime is positive, which is above the x-axis. And if f is decreasing, f prime is negative, which would be graphed below the x-axis. Then we also want to look at concavity. So where f is concave up, that means that f prime will be increasing. And where f is concave down is where f prime will be decreasing. And then the other things is that where f has points of inflection, f prime will have mins and maxes. And then, of course, we're going to connect the points to sketch the curve. All right, now we're going to go the opposite way. So now, if you're given f prime and you want to sketch f, you're going to locate x-intercepts and decide what they are. Are they mins, maxes, or level points? So again, if you think about a graph of f prime, if your x-intercept is going from below to above, that's going to create a minimum. So that's what your derivative would look like. A maximum is when your x-intercept goes from above to below, and a level point would just bounce off. So that's how you decide what the x-intercepts are going to be. The next thing is, you remember f prime being positive, which is above the x-axis, means that f is increasing. F prime being negative, which is below the x-axis, tells us that f is decreasing. If f prime has mins or maxes, those become points of inflection. Those will become points of inflection. And then again, if f prime is increasing, that tells me that f is concave up. If f prime is decreasing, that tells me f is concave down. And then we would connect the points. All right, so this is a difficult concept. Today, like I said, we're going to focus on this red part. And then tomorrow we'll do the opposite way. So we are going to ignore, we're going to, given the original sketch f prime, we're going to cross off these instructions, and this is what we're going to do for the 3 graphs on your notes. We're only going to sketch f prime given f. So this first one, this red line here, that is f of x, and we're going to sketch f prime. Okay, so I'm going to kind of look at this in intervals here. So from here, right there, I have a horizontal tangent. So that's going to become an x-intercept. Okay, so then I'm going to look at this portion of the graph right here. And in that portion of that graph, the function is increasing. So f is increasing and concave down. So if f is increasing and concave down, f prime is going to be above, f prime is going to be positive and decreasing. So we're going to be above the x-axis and decreasing. So I'm going to be above the x-axis and decrease till I get to that point. Now the next section right here, that portion of the graph, f is decreasing, but still concave down. So that means that f is going to be below the x-axis, but still decreasing. And right here, there's a sharp turn, so that the derivative would be undefined. Okay, and then the last section here, that graph is increasing, so f is increasing, but it doesn't have concavity. So if it's not concave up and concave down, that means that f prime is not increasing or decreasing. It's just going to be flat. So, which should make sense because the derivative of a line is the slope of that line. So f increasing means f prime is positive above the x-axis, but it's going to be a flat line because it doesn't have concavity. So I'm going to go, I don't know, up here, the slope of that looks like around 1. So I'm going to draw an open circle and just draw a flat line. And so that blue graph is F prime. All right. The next example. So again, this is f of x. So what I'm going to do is I'm going to label my horizontal tangents with points. And I'm also going to look where my points of inflection are. So this is concave down, and somewhere there goes to concave up. And then about there, it changes to concave down. And then maybe somewhere around there, it changes to concave up again. So now when I graph the derivative, I'm going to start with these horizontal tangents. They become x-intercepts. And again, I'm going to kind of look at the graph in sections. So like this first section here. Sorry, I don't know why it snapped into a straight line like that. So that little section is increasing and concave down. So that means F prime is going to be above the x-axis, but decreasing. So above the x-axis and decreasing till I get to that point. The little section in here, right here, that portion is decreasing and still concave down. So that means the derivative is going to be negative and decreasing. Then the next little section, I'm decreasing but concave up. So that means I'm still below the x-axis, but I have to start increasing again. And there you can see your point of inflection turned into a minimum. Then my next section here, my function's increasing, so f prime will be positive, and I'm still concave up. So that means I'm going to be above the x-axis, but still increasing. Then the next section here, I am still increasing, but I turn to concave down. So I'm still above the x-axis, but I'm going to be decreasing. So I have to go back, and then I eventually get back to my x-intercept there. And my next section here, I am decreasing and concave down. So my derivative is going to be under the x-axis and decreasing. Then the next little section here, I am still decreasing, but now I'm concave up. So I'm decreasing, so I'm still under the x-axis, but I'm going to be increasing because I'm concave up. And then that last little piece is increasing and concave up, so above the x-axis and increasing. And that blue line is F prime. Whew, this is hard stuff. And again, these dips and valleys, they don't, or hills and valleys, they don't matter how high and how low you go. All right, the last one I want you to try on your own. Again, we're going to ignore these directions. We're just going to say that this graph is F, and I want you to sketch F prime. So I put dots for my horizontal tangents. I'm going to put dots where I think the points of inflection are. And then I'm just going to start sketching with the different intervals. First one is decreasing and concave up. which means I'm under the x-axis. Oh, I didn't make my x-intercepts. So I'm going to be under the x-axis, but increasing. Next little section here. I am increasing concave up, so I'm above the x-axis and still increasing. Next section there. I am increasing and concave down, so that means I'm above the x-axis, but I'm going to be decreasing. This next little section, I am decreasing and concave down. So that means I'm going to be under the x-axis and decreasing. Then this next section there, I'm decreasing and concave up, so under the x-axis, but increasing. And then the last section here, I am increasing and concave up, so above the x-axis and increasing. And there you have F prime. All right, so tomorrow we will do notes going the other way.